Hello. So today what we're going to do is we're going to build some really super simple circuits that deal with both sound and light, and it's going to be based largely on Chapter 15 of Chris Adams' book. And we're going to be using the PRT motherboard and Teensy only for a power supply. We're just going to be using its regulated power supply to power up this breadboard and build some very, very simple demonstrative circuits. Before we actually jump into that, we should take a look at the settings on the motherboard itself. Okay, so I'll zoom in a bit. Alright, notice that I have a red wire here plugged onto this center row of pins. These are the ones that are going to be providing a positive current. These are going to be the positives. This outer row of pins, okay, which I can't quite see there, I'll move that aside. The outer row of pins are all common ground. It's important to realize that this jumper is set on the 5-volt side, not on the VN. There is no battery, okay, and all power is going to be coming from the USB. The red light should be on as soon as it's plugged in because it doesn't have a choice. Once it's plugged into your computer and powered up, this light will come on. You will not be able to turn off this switch. This switch still works, and I can turn it on and off. And that turning on and off will turn on and off the power, 5 volts, and allow us to use it via these two wires here. At the moment, I do have these two wires hooked up. I have the red wire in the common bus, okay, along this red band, and I have the black wire along this blue band, okay. So all these holes along the blue band are going to be commonly hooked up to the ground, and all of these holes along the red band are going to be commonly hooked up to the power. I should state, you might see from time to time at this end of the board, I do actually have an LED hooked up, and I'm got a 330 ohm resistor going from the power to the same column of pins. So this wire here is connected to the anode side of the LED, and we'll talk about that more in a little bit. And then the cathode side here is going to the same column of pins as this black wire, which is hooked to ground. So I have a complete circuit. Resistor to anode, LED to ground, and if I turn on and off the switch, I turn on and off the circuit. Okay? So that being said, let's talk a little bit about sound to start with. And what I wanted to show you are two very similar looking objects. And when you're working in the classroom, you'll probably find a lot of things that look fairly similar. They're not the same. They're basically two types of canisters that look like this. Okay, they're both piezos. They're vibrating crystals that pulse it. When you provide electricity and pulse it, they begin to vibrate a metal disc, which will generate sound. Now, some of these have a driver in them. Okay, so if I power it up, it actually has a pulse generator that keeps that metal diaphragm moving back and forth, and it's going to generate a continuous tone. Others do not. Okay, and the easiest way to tell, if you don't happen to know which ones they are, they both do have polarity. I don't know if you quite see it, but one wire is longer than the other, and there should be some indicator. For example, this one has a positive here, and this one has a positive on the top. Okay, and if I hook this to a 9-volt battery, this is positive. Alright, so I'm going to take the positive to the positive. It makes a sound. Alright, this one is a buzzer, so it will make a single sound, and the only thing you can really basically do with it is change perhaps the volume. You can play with the pitch a little bit, but it's already got its own pitch built in because it's vibrating at its own beat. This is an element, and if I hook it up, where's that positive at? There we go. It will not do that. It'll just make a click. See if you can hear it again. Alright. This thing needs an external force drive the disc, And it's really kind of handy because if I do provide it with different pulses, I can actually change the tone. So this one will play a musical melody. This one is primarily just a buzzer. All right, so let's just make it go. We'll turn off the power on the board. It's already off. And I'm going to take the positive side of this. Actually, I'm going to put the negative side, okay, into the ground. And I'm going to take this red wire here. I'm going to plug it there. And you can see, actually I should move it so you can actually see it. I'll zoom out a little bit. That if I click the switch, okay, provide current, and the buzzer goes. All right, not particularly exciting, but it's important to realize. I should show you this. If you hook it up backwards, nothing happens. Okay, it's dead. It does have polarity. And I might suggest you do that because I suppose it's possible to damage it, but I know this one is pretty robust and it was not damaged. I'm going to pause this and build a little more complicated circuit. I'll see you in a second. Okay, so here's a circuit you may want to build yourself. It went pretty quick. So notice what I've done here is I've added a switch. Okay, this switch is going to, one end of the switch is hooked up to the positive. I now have the other end of the switch hooked up so that it goes to that positive bus, right? So the switch is going to essentially turn on and off the flow to this entire bus. I have this little jumper wire here, which is going from that positive bus to the positive side of the piezo buzzer, and then I have the ground going here. Notice this light is already on and there's no buzzer. That's because I have to push the switch, and that gives it continuity and allows a complete circuit from positive to ground through the piezo buzzer. Okay, I would suggest you actually make this work yourself. It's not going to take long, and it will get yourself somewhat familiar with the circuit. I do want to point this out on these little buzzers, if this is what you use, that I'm going to stick this guy upside down here so you can kind of see it's from the underside. All right. They are a little bit odd and sometimes deceptive. This one and this one, okay, the two that are facing inward, these are the ones that switch on and off. These also switch on and off, okay. These two do not, and these two do not. So in a circuit like this, where you see I have these wires spaced apart only with a single space, so it's this column here is all connected. This is not used. This is all connected. And if I take and insert this switch like this, okay, it works. If I tried it the other direction, it probably actually wouldn't fit comfortably. In fact, it doesn't, and it wouldn't work. All right. So let me pause this, and I'll build another little more complicated circuit. Okay, so this particular circuit is not yet complete. I'm leaving out this component for the moment so you can kind of see the wiring path. So the electrons can travel down this red wire here. This is going to be our positive. We have the switch, which is connected to the bus. So I push the switch. That's going to connect the positive to the bus. And here I have a red wire that jumps to this column here. Okay. Yeah, I wish I could move that further away so you can distinguish it from the yellow. All right. Goes to this column here. This yellow wire here goes to the positive of the piezo. The ground is actually plugged directly into this bus. Okay, so I have a complete circuit there. And then this last wire right here goes straight to ground too. So this column, and this column are all going to be used. None of these are currently connected, so I'm going to have a device that goes between these three columns to make it go. Well, the device I'm going to use is one of these. Okay, this is a variable resistor, potentiometer, oftentimes just called a pot. And if I were to break it apart, I think I talked about it in one other video, there would actually, let's look at it from the back side. Well, there's three wires there. This outer wire here and this outer wire here are connected inside by a long resistor that coils itself around. Okay, so there's a fixed resistance between here and here. This middle wire physically rides on a metal piece that slides around here. So if I have the knob turned, for example, in this direction, okay, it now is physically very close to this wire here. So it'll literally be like a little knob that reaches across. So it's a very short path from here to the center. And it's a very long path from here, from the center to this outer edge. As I turn this way, okay, the metal disc now, the metal rod now gets closer to this one, and the resistance between here, the center, and this outer edge is very small, and the resistance from here to this edge here is very high because it's very far away. So the current has to travel all the way over here and then jumps out to the middle. All right. So if I stick this into these three holes, this is the positive. This is going to ground. Remember, this thing is a fixed resistor on the inside that goes from this pin to this pin. So we're going to have a path, a resistive path, all the way around. So we will actually have a way for it to get from here to ground. But then we're going to have an escape path, a variable escape path that's going to be hooked up to the center, which is going to go to the piezo. So if I hook this up and I insert it into those three holes and push the button, we can then change the volume and a bit of the pitch by allowing the electrons to be able to flow at different resistances, giving them different escape paths out that center pin. Okay? So I'm going to pause this. Perhaps you should build something like this yourself, or one that's demonstrated in Chris's book, and make sure it works for you. But I'm going to build another circuit, and I'll see you in a second. Okay, so let's actually build a simple light circuit. All right, and I'm going to introduce the LED briefly again here. There's a couple things you need to know about it. If you have a brand new LED, all right, the anode, the one that's going to hook to the positive, the wire is going to be longer than the one that hooks to the ground. Okay. Also, which is hard to show on this camera, but if you looked carefully, I'll look at this one, maybe it's easier to see. There's a flat. If I shine the light just right, I might be able to show it to you. Oh, wait, there it is. See, it's flat on this rim. Okay. That also is going to be the one that's closest to the shorter wire and goes ultimately to ground. I typically like to work these guys by taking the longer wire and bending a little knee in it. Okay, so I can quickly and easily see that this is the one that's going to go positive and this is going to go ground. So if I want to build a circuit to power an LED, I start off with a resistor. In this case, I'm choosing a 330 ohm, which is going to allow enough current to flow that we're going to get a pretty bright LED. And not, if I put a bigger resistor, it'll get dimmer and dimmer. Eventually I won't be able to see it. If I put in a resistor much smaller than that, much less than, say, 200, 300 ohms, I actually risk the chance of putting too much voltage into it and popping my resistor. Popping the LED. So let's take and plug this guy in like this. So I've got the positive. I got the positive on this side going to the resistor, going to the knee, bent knee, which is going to the anode side of the LED. And the last thing I need to complete this circuit is to hook it to ground. And lo and behold, it lights up. Okay, and I can turn it on and off with this switch. Let me add a few more, and we'll be done with this in a second. Okay, we're going to wrap this video up quick here. So you can see what I've done here. I've actually just added two more resistors, each of them at 330 ohms. They're hooked up to these columns. So these wires here, all hooked up to the anodes, these bent knees, go to the same columns. So this will hook to positive. This then ultimately hooks to that resistor to positive. And then I have three grounds, obviously going to ground. So if I turn it on, they all light up. All right. Let me dim this for a second. All right, so I've adjusted the contrast, so now you can actually see the three different colors. But that's basically it for Chapter 15. You should be able to understand how to build all these circuits, understand the difference between the anode and cathode, which one goes positive and negative, and the resistors and basic circuits. So I will see you guys again soon.